I'm going to run through this practice test on Unit 8, problems involving percent. So let's make sure we keep track of the instructions. Always a good thing to read. We want to make sure we show all our work. We want to circle our answer so it's clear what we think the answer is. And please make sure you round to the nearest hundredth. So we're talking 2 decimals on this, especially where applicable. So on this one right here, just a basic old percent problem. It says 85% of 160 is what number? We're going to translate this into an equation. So we're going to do 0.85. The word of means multiplication, so that's multiplied by 160 is what number? We don't know what that number is, so we're going to use an X there. Again, I've just automatically translated the 85% into a decimal. We move the decimal over 2 places when we type that into an equation or a formula or something like that. So here we go. We're going to do 0.85, and we're going to multiply that by 160. Hit enter and see what we end up with. In this particular case, we end up with 136, so we're going to do 136, circle that, and we're all done. So 85% of 160 is 136. We're expecting something a little smaller than 160 because it's 85 is less than 100%. So if this was 100% of the number, we want something that's 85% of the number, a little bit less than that, so 136 looks pretty good. Next one, 6 is, in other words, 6 equals what percent? We don't know the percent of 48. Now remember, of in most cases, especially here, means multiplication. So we're going to go ahead and divide. So divide by 48. I'll grab the calculator here in just a second, and we end up with 6 divided by 48. 6 divided by 48 is 0.125, so we're going to do 0.125. The P reminds us that this is a percent, and that right there is a decimal. So what we're going to do, we're going to turn that into a percent by moving that over 2 places, so it represents that whole per 100 thing. So this is going to be 12.5 per 100%. So there we go right there. That's the answer. We don't need to round or anything because we haven't gone past 2 decimal places. So we'll take a look at the next one. 18 equals 39%. So again, we're going to do the same thing here. We're going to do 0.39 of what number? We don't know what the number is, so I'm going to use an X for that. So again, notice I'm using X for the number and P for the percent. That helps me remember that when I get an answer that has a P on it, I've got to move that decimal over 2 places so that it represents the percent. So we're going to divide by 0.39 here, 0.39 here. Those are going to cancel, so we get X is whatever that is. So we're going to do 18 divided by 0.39. There we go. Okay, here we end up with a little bit of a mess. This is a number, so it's going to be 46.1538. So 46.1538. Now, this is the number. We're not moving the decimal or anything like we did over here with the percent. So we just need to round this to the nearest hundredth, 2 decimal places. So that's a 5. We look 1 past that. This is a 3, so that's not enough to bump this up. Remember, if we're rounding to the nearest hundredth, this is either going to be a 15 or a 16 if we have to round it up. It's not enough to round it up, so we're going to leave it this way. 46.15. Make sure you circle that answer. 64% of 118. So what is? We don't know what the number is. Is means equals 64%. Again, we're going to move that over 2 places, and then of means multiplication. So these are actually the best ones. These are really easy. There's no solving to do here. It's kind of like that first one. So we're going to go ahead and hit this, and we're going to type in 0.62 times 118, and let's see what we get. So we get 73.16. Again, it stops right there. It doesn't go on, so we don't need to worry about rounding. So 73.16. We're going to circle that answer, and we're all set to go. Okay, we'll slide down on the next one. Now, I do want you to notice that this one right here has an asterisk by it, and I'm going to show you why. This one has the original, and this one has the new. This one has the old, and this one has a new. So we're kind of mixing vocabulary there. This one has new, and then it has the original. Okay, so we want to make sure that we're careful, and this is kind of a story problem that we're going to have to read. It says find the percent change to the nearest hundredth and state whether it is an increase or a decrease. So remember this, the new one is always some percent of the old one, or the original one. So here's what we've got on this one. This is 160 is the new one. Okay, so 160 is some percent, we don't know what the percent is, of the original one, of 100. If you have any trouble remembering that, just get this memorized. The new one is always some percent of the old one. And you can say new and old, you can say the new one and the original one, whatever you want to do there. So I'm going to translate this into an equation. So this is going to be 160 is equals some percent of 100. So we're going to times that by 100. We're going to divide by 100 right here. Cancel these off. And this is one of those interesting ones where if you throw that into the calculator, and I'll do this just for fun, 160 divided by 100, some of you might know what the answer is right off the top of your head. It's 1.6. If you get something like 1.6, you're thinking, gosh, that looks great. That's the answer right there. But remember, this is what the P reminds us of. This needs to be a percent, so we need to move this over 2 decimal places. So this is going to be 160%. And remember, this is not the answer, because what we're trying to find is we're trying to find the percent change, and we're always comparing it to the original. So I'm going to subtract off 100, and I end up with 60%. Because this is positive, we know that this is an increase. So this is a 60% increase. Now this problem's on here for a reason, because if you stop and think about it, these numbers 160 and 60 and 100, they've been floating around throughout the entire problem. If the original one was 100 and it went up to 160, it went up 60%. And that's how we can see this, because if it went from 100 up to 60, the change, the difference here is 60. It turns out to be positive, so it's got to be an increase. All right, on this one right here, we've got to make sure that we put these in the right order. So remember, the new one is some percent of the old one. So the new one is some percent of the old one. All right, so here we go. The new one, so that's the 19.45. 19.45 is some percent of the old one. The original one is 6.35. So 19.45 equals P times 6.35. So we're going to divide by 6.35. Cancel those off. We're going to throw this in a calculator because that's a nasty mess. 19.45 divided by 6.35. Make sure it's all typed in there the right way. Everything looks good. And we get this big ugly mess right here. So I've got a P on this side, and then over there we've got 3.06299. 3.06299. Bring that up again. Always good to double check and make sure that we got it written down correctly. We do here, so we're in good shape. But remember, this is a percent. So what I need to do is I need to move this over 2 places. So this is going to be 306.299. So let's think. This is either going to be 29 or it's going to get bumped up to a 30. That 9 is enough to bump this up. So we are going to make this a 30, so 0.30. And remember, this is a percent. So that's not the final answer because we want the percent change. That's what percent it is of the original amount, but we want to subtract off that original percent. So we're going to subtract off 100, and we end up with 206.3. If you wanted to put 30, that would be fine. So it's a 206.3% increase. So I'll write the word increase right here. And again, we know that it's an increase because this turned out to be positive once we subtracted, and it went from 6.35 to 19.45. Okay, so we've got that one taken care of. Let's take a look at the next few. So let's take a look at number 7. So we've got the old price is $93, the new price is $70. So the new price is some percent of the old price. So 70 is some percent of 93. So 70 equals P times 93. We'll divide by 93, get rid of that, grab the calculator and see what we come up with. 70 divided by 93, hit enter, and we get 75.752688. So 75.2688. So 0.752688, that's what equals P. Just double check here and make sure we got that right. Looks pretty good. And then remember, that's a percent, so we're going to move that over 2 places. So 75 point, we're going to have a 26, and that 8 is enough to bump it up, so we're going to call that a 27%. Always subtract, so we're going to subtract 100%. So I'm going to grab the calculator and do this. 75.27 minus 100. Let's see what we got here. Minus 24.73. So negative 24.73. And remember, that's a percent. So what that means is it went down that many percent. So we're going to say 24.75. Let's see, did I get that right? 73, sorry about that. That's a 3 and that's a 3. So it went down 24.73%. So that's a 24.73% decrease. So that's a decrease on that one. So we'll go ahead and circle there. All right, again, that negative indicates that it's a decrease. These both ended up to be positive. Let's see what we have here. Last week, students sold 44 magazine subscriptions. This week, they sold 99. So last week would be the old one, and this week would be the new one. So the new one is some percent of the old one. So 99 equals some percent times the new one, the old one of 44. So we'll divide by 44. And again, I've skipped on this one, writing that the words there. So let's take a look and see what we get. 99 divided by 44 equals 2.25. Okay, so we get 2.25 equals P, which if I move that over two places is 225%. But then we've got to subtract off the original percent, so that leaves us with 125. And the fact that this is positive means this is a 125% increase. 125% increase. We're going to circle that. So what that means, 100% increase is like doubling. Well, if they had doubled their sales, they would have gotten to 88. So they actually did a little bit more than double. Okay. All right, let's slide down here and take a look at the bottom of the page here. This one says find the final cost to the nearest cent. All of these are about money. We've got some tax problems over here and some tip problems over here. So remember, the tax or the tip is a percent of the price. Okay, so tax / tip is a percent of the price. Percent of the price. So let me make that look a little bit nicer. So the tax is, let's see, some percent, 7.5% of 39. So we're going to go ahead and say tax equals 0.075 times 39. That's going to tell us what the tax is. So we'll grab that and we're going to do 0.075. And that's going to be times 39. That's going to tell us what the tax is. And let's be smart about this. It's 2.925. We want to round this to the nearest penny. So this is $2.92 and a little bit more. That little bit more, that 5's enough to bump it up to a 3. So this is $2.93. So the tax is $2.93. So if that's the tax and we add it to the original price of $39, this is going to be, so let's do tax right here and then add the 39. So this is going to be $41.93. $41.93 for the whole price. So we want to have the tax right here and we want to find the final cost. It does just say find the final cost, so this right here is kind of extra. So I think what I'll do is I'll just put a dotted line around that. And I do want to show you that other way that we did this. It's really quick, so let me do this in a different color. So on this one, we're going to have to pay 100% of the meal. Plus, we're going to pay 7.5%. So altogether, we're going to pay 107.5% of the price. So in this case, it's going to be 1.07.5 times the price of $39. Now watch what happens when we type this into the calculator. Move the decimal over two places. The 1 represents 100%, and take a look at this. This is the 0.075 that we had here, times 39. Grab that calculator. So here's what we'll type in instead. And this is why I like this, because it goes a little quicker. If all we have to do is find the final price, 100% of the original price, here's the tax, the 7.5% tax, times 39. Hit enter. We've got 41,925. That 5's enough to bump that up to a 3. So it's 41.93, same answer there. So I really don't care which way you do it. I kind of like this way. I'm going to do both on this one, and then I'm just going to do this little quicker method here. So let's take a look here. So this is going to be, we're going to leave a tip. Okay, so the tip is 15% of 38.75. So the tip equals 0.15 times 38.75. We'll grab the calculator. So we've got 0.15 times 38.75. Let's see what that tip is. $5.81 and a little bit more. Not enough to bump that up. Okay, so we're going to do $5.81. So this is the tip equals $5.81. We're going to add that to the original price of 38.75. Let's see what we get here. So 5.81 plus 38.75. Got it typed in there the right way, so we get 44.56. Okay, so 44.56. Again, we want to have the label on there, so it's $44.56. Again, very quickly. 1.15, there's the 100% of the price plus the 15% tax, and we're going to times that by 38.75. Grab the calculator and we'll clear this off, and we're going to do 1.15 times the 38.75. And we'll hit enter, and lo and behold, 44.56 and a little bit more. Not enough to round it up, so there's our 44.56. So we're in great shape. Again, from here on, I'm just gonna do it the short way. So let's go ahead and take a look at this. We're gonna pay the price of the bouquet plus 5%. So that's gonna be 105%, which I'm gonna write as 1.05. Of the original price. The original price is $48. So we're going to do this, grab the calculator. I'm going to slide this over so we can see it. 1.05 times 48. 50.4. Now, if we write down 50.4 and say, hey, how much does that cost? And somebody says, hey, it's 50.4. It's not 50.4. It's $50 and not 4 cents, 40 cents. So let's make sure that we put that on there. And then we've got an 18% tip. So again, 100% plus the tip, 0.18. Again, move that decimal over. That's why it's 1.18. 100% for the price we're going to pay. Then the 18% tip, 24.33. Grab the calculator. So we're going to do 1.18. These go very quickly once we get used to how to do these. Make sure it's in there the right way, and we end up with 28.7094. So this is $28.70 and a little bit more. Is that little bit more enough to bump it up? It is. It's either going to be 70 or 71. That 9 makes it a 71. So 28.71, and we're going to put the dollar sign on there, and there's our answer. Let's go ahead and take a look at this other side. We've got this table here with a whole bunch of information in it, and then some things missing. This is similar to the one where we did the markup and discount. We were finding the change, new price, old price, all that sort of stuff. So let's take a look at this one and then see if we can remember how to do these. So the old price is $9.25. The percent change is 20%, so they're going to mark it up 20%. And then we want to find the amount of change. So what we're finding here is we want to know what is 20% of that right there. So this is going to be what is 20% of 925. So in other words, x equals 20%, so that's going to be 0.20 times 925. So I'm going to grab the calculator, we're going to type that in, we're going to do 0.2 times 9.25, and we end up with 185. Now since this is money, we're going to say this is $1.85. Okay, and that is an answer, so we need to fill in each one of these boxes here. Now in order to get the new price, so if this was a discount, this actually went down, okay? So it went down 20%. So we're going to take the 925. So remember, if we get a discount, we're going to subtract whatever that change is. So 925 minus $1.85. So grab the calculator, 9.25. And we're going to subtract 1.85 and hit enter, and we get 7.4. So we have 7.4 right here. But remember, this is about money, and like we said before, we're not going to leave this like this. We're not going to say it's $7.4. We're going to say $7.40. Okay? So this was a discount. That clues us in that the change was going in a downward direction. We'd have to subtract when we're done. Now, it is possible for you to find this one right here, and we talked about how to do that, and then go backwards and figure out what the discount was. Lots of different ways to do these. I'm going to stick with this for right now. Okay, so the old price was $40 and the new price was $52. So we want to know the amount of the change. Well, the amount of the change was, we'd do 52 minus 40, so we end up with 12. So the amount of change was, $12. Okay, so $12, and it went up. So that was a markup, is what we'd call that, mark up. Okay, we could also call that a price increase or something. So then what we want to do is we want to figure out, gosh, if we know these two things, what was the percent of the markup? What percent did it go up? So the amount of this change is this percent of that right there. So we're going to say 12 is some percent of $40. So 12 equals P times 40. We're going to divide by 40, and we're going to get P equals, grab the calculator here. Again, we're doing, let's see, 12 divided by 40. So 12 divided by 40, and we end up with 0.3. So what that means is 0.3, that's a percent, move it over 30 to there, so we get 30% markup. 30% markup. Okay, or an increase of 30%. So these next two are kind of interesting because we've been studying percent problems for a long time, and we've done a bunch of different types. This is kind of embedded in this table. It's not really a markup or a discount, but it does show some improvement on this one, a 30% improvement, and on this one it shows a 5-yard loss. So we really need to think about what's going on here. This is the old one, and it showed a 30% improvement, and they ended up with 852 points. And we want to figure out, well, what was the old one, and what was the amount of the change? What was the actual point improvement? So remember, the new one is always some percent of the old one. Okay, so that means that 852 is, now remember, this is 100% of the original one plus whatever that improvement is. So this is going to be 130% of the old one. So 852 equals 1.3 times the old one, and I'm going to use an x for that. So then we're going to divide both of them by 1.3. So if we divide both by 1.3, we get x over on this side, and we're going to grab this and we're going to say, okay, what is 852 divided by 1.3? And we end up with 655. Okay, so we're going to round to the hundredths place. So this is going to be 655.384. That 4 is not enough to bump it up. So this is going to be 655.38. 655.38 points. And I'll just put PTS here. PTS right there. Okay. Well, what that means is if we went from 655.38 all the way up to 852, we can actually figure out now what was the actual point improvement. So we're going to do 852, and we're going to subtract 655.38, and we are going to do a subtraction problem here. So we're going to do, clear this off, 852 minus 655.38. And we'll hit enter. 196.62. So 196.62. Okay. All right. So we've got that one taken care of, and then let's take a look down here. Let's see. We've got 12 yards to begin with, 5-yard loss. So what that means is it's going to be 7 yards is going to be the end result, the new result. Okay, and we want to find the percent here. So there's a couple different ways that we can do this. So what we can do is we can say, well, this change is some percent of this right here. So 5 is some percent of 12. So 5 equals P times 12, and we're going to divide by 12. So we're going to cancel that off. So we're going to do 5 divided by 12. And we're going to hit enter, and we're going to get 41.66666. Okay, and we're looking for a percent, so this is 0.416666. We're going to move the decimal over 2 places, so this is going to be 41.67%. And in this case, it wasn't an improvement, it was kind of like a decrease. Okay, it decreased from 12 yards down to 7 yards, which was a 41% decrease. So I'm going to go ahead and circle that. Now, there are some other ways to do these problems. I want you to take a look at this and consider this. The new one is 7. It's some percent of the old one. So I'm going to change colors here. And if you wanted to figure it out this way, you could. So we could do 7 is some percent of 12. So there's an equal sign right there. We're going to divide by 12. So we end up with, let's grab 7 divided by 12. So 7 divided by 12. Hit enter, we get 58.333, so we're going to leave it that way. So 0.58333, move the decimal over, so it's going to be 58.33%. This is 58.33% of 12. Well, remember, we're always comparing to the original, so watch what happens if I take that, so 58.33, and I subtract 100% of the original. 41.67, and notice that it's negative. So this is kind of like having an increase or decrease problem, just kind of embedded in here, okay? And remember, the key to solving these is please make sure you show your work. There are lots of different ways of doing percent problems. Just make sure you think about it and are able to show your work to back up what your answer is. Okay, next one, it says find the total bill for a dinner that costs $35.22 and you want to leave a 15% tip. Okay, well this is kind of like what we had up above, but this is kind of written out for us. So we want the total bill. So the total bill is going to be, we're going to pay 100% of this, okay, plus a 15% tip. So if we figured out the quick way that we did up above, this is going to be, this is going to be 115% of the bill, 35.22. So that's going to be 1.15 times 35.22. We're going to grab the calculator and type that in. Let's see what we end up with. So 1.15 times 35.22. Make sure we got it right there. Yep, looks good. So this is 40.503, so that's $40.50, a little bit more, but that little bit more is not enough to bump it up. So the answer is going to be $40.50. And the key here is it did say total bill. Okay, we wanted to know what the total price was before we go. Okay, Sarah works in an appliance store. She earns 12% commission for sales up to $6,000 and 18% on sales over $6,000. Last year her sales were $7,200. How much was her commission? So the first thing we want to do is we want to break this up and say, okay, she did sell more than $6,000, so she's going to get paid a 12% commission. Okay, so we'll say at 12%, and then we want to write down what's left. Well, what's left is if we do 7,200 minus 6,000, we end up with 1,200. So she's going to get paid $1,200 of sales at 18%, so at 18%. So I'm going to call this commission number 1, and I'm going to call this commission number 2. So commission number 1 and commission number 2. Okay, commission number 1 is 12% of 6,000, so 12% of 6,000. And commission number 2 is 18%. 18% of 1,200. So 0.12 times, the of means times, multiplied by 6,000. 18%, so that's 0.18 times 1,200. So if we throw these in the calculator, let's see what we end up with. We end up with 0.12 times 6,000. Hit enter, 720, so she gets $720 from that. And the other one would be 18% of, so times 1,200. And we'll hit enter, $216, so 216. So then we're going to add those together. If you add those together, it's $936 even. So we're going to go ahead and circle that. So $936 is her commission on that. Okay, last one. Mr. Laws wishes he had $98,200 in a bank account bearing 7.25% simple interest. If he did, and he left it there for 3 years and 3 months, how much money would he have? Okay, well, we got to remember the simple interest formula. I equals PRT. So if I equals PRT, let's take a look here. This is the amount in the bank, so that's going to be the principal. So the principal's right here. This is the interest rate, so that's going to be R. And the time is 3 years and 3 months. So 3 years and 3 months out of 12. And this is the key right here. We can't multiply it by 3 and 3. We've got to come up with a decimal for this right here. So this is 3 and a quarter. A quarter of a year is 3 months, 3.25. Okay, and that's going to be T. So when we plug this into the formula, the interest is going to be $98,200. Gosh, it would be nice to have that much money. The decimal is 0.0725. And we're going to times it by 3.25. So we're going to grab the calculator, throw that into the calculator, and see what we end up with. 98200. We're going to times that by 0.0725. And we're going to times that by 3.25 because 3 is the full number of years, and then we did a quarter of a year. Go ahead and hit enter, and we end up with, okay, so what do we have here? 23,138 and a little bit more. So 23,138 point, let's take a look. That's 37 cents. 37 cents and a little bit more. Is that a little bit more enough to bump it up? It is. Okay, that 5 bumps that up to a 38. Okay, so it's $23,138.38. Now, that is the interest. The question is, how much money would he have? So we have to take that. That's the interest, and we're going to add the principal of $98,200. So we're going to take that last answer, and I'm just going to hit plus. It'll grab that last answer so I don't have to type the whole thing in again. And I'm going to do 98,200, hit enter, and we get an answer, 121,338.375. Remember, that's going to bump it up to a 38. So 121,338. 121,338.38. Put a dollar sign in front there, circle that, and we are all set. Okay, that was the last of the percent problems, but don't be surprised if you see a review problem on this test or any other test. So let's go ahead and do this one right here. You can use your calculator for these. I don't have a problem with that at all, especially where we've got some decimals over here. But we do want to see what we can work out on our own. So if we take a look here, we're going to multiply here, so that's going to be 2/3 x. Multiply here, that's going to be minus 2/3, and then plus 1/3 equals 2/3 x, and then distribute the negative through, so that's going to be minus 5 and then plus 1/2 x. So let's see what we get here. We want to combine these together, these numbers together. Whoops, that's a 1/2. I better not make that mistake. Okay, yep, we're good there. Okay, so this is going to be negative 4/6 plus 3/6 if I get a common denominator. If you want to do this on your calculator, totally okay. This is 2/3 x, and then this is going to be minus 1/6. And then over on this side over here, we've got to combine the two of those. So we've got, this would be 4/6x plus 3/6x. So that's going to be 7/6. Yep, 7/6x. And then the minus 5. And I'm going to zoom in here just a little bit so we can see what's going on, because these are getting fairly small. So I'm going to slide over here and let's see what we got. We now want to move one of these. This is a little bit smaller. We've got the two sides simplified. 2/3 is smaller than 7/6. You can tell because the top number is bigger here. So I'm going to subtract 2/3 x. So that's going to get rid of it from this side. At the same time, I'm going to add 5. So I'm going to add 5 here and add 5 here. So I would grab the calculator just to double check and make sure. I'm going to have a little bit of fun by doing this by hand. This is the same as 4/6. So I've got 7/6 minus 4/6. That's 3/6. So what that means is this is 1/2 x. So this is 1/2 x. We got rid of that over there, and I've got negative 1/6 plus, let's see, over here we would have 5 over 1. That's negative 1/6 plus, if I get a common denominator, that's 30. So this is going to be negative 1 plus 30. That's going to be 29/6. Oops, 29/6. And then I've got a fraction in front of the variable, so I'm going to multiply by the reciprocal. So that's going to be 2 over 1. 2 over 1 here. Those are going to cancel. I'm going to get x on this side, and then I'm going to do a little bit of cross canceling. I get a 3 there, and the cool thing about this is 29/3, and that right there is the answer. I do want to show you something that you might want to notice in the future. If you notice that we've got 2/3 x here and 2/3 x here, those two would be gone, so it shouldn't be any surprise that over on this side we end up with a 1/2 x, because if I subtracted 2/3 x from this side and 2/3 x from this side, that would go away, and then I've just got the number on this side, the number on this side, and then the coefficient with the x there. Okay, so that's the answer on that one. I'm going to slide over here and take a look at this one. This one goes a heck of a lot quicker. We want to get rid of the dividing by 2.1, so I'm going to multiply both sides by 2.1. Notice that second set in parentheses. 4.1 minus x equals, and we're going to multiply here. I believe this is 10.5, but let's just go ahead and check. So we end up with 5 times 2.1. We end up with 10.5, so we're in good shape there. I'm going to subtract the 4.1 from this side, so subtract 4.1 there. So we get negative x equals, let's see, 10.5, so I'm going to subtract 4.1, and we get 6.4. Now, I've done something here that a lot of people forget to do. Notice this negative goes right here. A lot of people will just say, oh, the answer is x equals 6.4, and then they'd circle that and they're done. It's not 6.4, because remember, we don't want a negative x, we want a positive x. So if you wanted to go through and divide by a negative, or you wanted to say, hey, I don't want a negative x, I want its opposite, which is positive x. I don't want 6.4, I want its opposite, which is negative 6.4. And there we go. There's the answer. Now, this takes quite a while to work through. Your test is going to be a little bit shorter. I think it'll go a little quicker. It also takes longer for me to talk about it and explain it at the same time. So good luck with that. Appreciate you watching, and I've got another practice test coming your way. See if you can do both and then get an awesome score on the test. Percent problems usually give people trouble, so work hard on it.